Hello. Hello, everyone. Well, that's a massive crowd. So, welcome to this session, a huge cluster or multi-clusters identifying the bottleneck. We'll try to squeeze as much as we can in the 30 minutes. I hope some of your questions get answered, else we are here for today, tomorrow as well. My name is Saiyam Pathak. I'm from Loft Labs, creators of vCluster, and I'm principal developer advocate, founder of Cube Simplify, Build Safe. I'm a Kubestronaut. You can connect with me at the Saiyam Pathak on any of the social platforms. I'm pretty active over there, and I'm joined by.
I'm Paco Xu from China, and I work in DaoCloud. I'm a member of Kubernetes steering committee and also a KubeADM maintainer. Yeah.
So we have a small kind of, not a quiz obviously, but we just want to take some idea of where things are. So if you can just scan, and there are just two questions. If you can just, it's anonymous votes, no sign up and stuff. I hope there is no sign up. So anonymous vote, if you can just do it, that would help us understand the dynamics of Kubernetes clusters, the size of Kubernetes clusters, how many Kubernetes clusters you are using. All right, we do have 44 participants responding, 39. That's cool. Okay, we'll not take much time though. So we'll just see the results of where we are. Well, that's a very good number of people having Kubernetes clusters greater than 100 nodes. And out of 239, it's 40%, which is a very massive number. Let's go to the next one. And having more than 30 clusters in your organization, well, that's again a very huge number. So everyone has those huge multi-cluster and big cluster problems. Well, that's cool. That's what we are here for. And let's get started. Let me share the slides again.
You can take this. This is a page from the Kubernetes.io. It's about consideration for large clusters. I think most of you may have already seen this. Here, we recommended for 5,000 nodes. This is a tested number by Kubernetes CI by SIG scalability. And this means this number is already tested. And meanwhile, these numbers here have not been updated for a long time. So here we have some updates. And for the previous public blogs, early days, OpenAI has scaling their Kubernetes to 2,500 nodes in 2018. And later, we can see there's Ungroup and OpenAI and also the Bayer. They have about 10K or 15K nodes for their cluster. And later, for ByteDance, they use Kubebrain to scale to 20K nodes. And last year in KubeCon North America, GKE has announced this scaling to the 65K nodes. And there's a demo yesterday if you see you are in the demo theater. And also before this, we have asked a question, and in the Reddit, this is a very hot topic. I think most of you may want to know the bottlenecks and the pain points here. And here's some feedbacks from the Reddits, like the events, like cluster outscaling and DNS, also IP tables or endpoints sync, and also, one thing is mentioned that node number is not the only good measure for the class size. Sometimes we need to the total object number, which may be more accurate. And also, some mentioned that for the large cluster, they need some multi-tenancy solutions. That is one of the pain points. Here are some general bottleneck if you want to build a big cluster, like the API server bottlenecks, like the etcd. This is talked many times. And also, DNS and storage challenges are one of the key issue on bottleneck. And node management and monitoring is also a problem when at scale. Here's the question: why we want a huge cluster? Like our city, there in the top 10 buildings in the world. I think there's 3 or 2 in Shanghai. We build the higher buildings, and also people like huge clusters sometimes. And this may reduce the maintenance costs and centralize the management and enforce the policies. And also, you can when you have multi rooms, so your cluster is will not fail for the single row failure. Those are the pros. And for the cons, you can see that for native Kubernetes cluster, if you use the namespace, it's not it's a little per tenant isolation, and also you may encounter the large cluster radius, and also some users may need different versions, so the end user or your team may have not flexibility, and also you should do the version selection if as we only support for the control plan is version N, and the node should be newer than N-3. So that's another problem. Also, the scaling challenges and custom node configurations is something sometimes is the requirements. And also, if you use some CRD or operators, they may have the version dependency. So and also this may depend on the Kubernetes release period and the support. Well, one version after release, the community may the long-term support is only about 1 year now, and maybe it will be 2 years, but this will depends on the work group LTS later. And I think the biggest problem here is the flexibility and the large blast radius. When you want to use a large cluster, what are challenges and solutions? I give a list, maybe not details, and we may mention some details of the solutions in the following pages, and maybe not all of them. And we will leave the links and what we attach in the slides, and you can check it later. So here, we should mention that for the API server pressure, we may use the rate limit and APF and also caching, something like that. And for scheduling, scheduler, you should choose a proper schedule for you, and also do some testing based on your scenario. And also the descheduler. And for etcd, it's one of the key problem we should address. This will be mentioned later. And for etcd tuning and the heartbeat and snapshot related, and also there are some etcd replacement like Kubebrain, like kine, and this will be talked later. And also you may have some read cache like Clusternet or something else. So this can make the pressure lower. And also, you should test those performance of all your management components and operators. And also, sometimes you should see your GPU and different GPUs and the CPUs architecture. And for the network, CNI is one problem, and gateway, and also DNS is sometimes you should know you should not. You should use some cache or scaling or some replacement like host alias for sometimes to make the DNS server in a good state. And also there's IP tables change. The current we have the NF tables, which will be GA in next release of Kubernetes this month. And also, you should take care with the pod IP range and also your node IPs. And also, sometimes if for the large cluster, it crosses rooms, you should know those affinity or something like that. And for storage, it's a big topic, so I may not mention much about storage here. And also for autoscaling, the Carpenter is joined the Kubernetes community. And also for users who the scenario HPA cannot cover, you may use CUDA. And also, you should do more tests with the large cluster before you extend your cluster to more nodes. So Quark is a good choice. And also, there's KubeMark. When you want to have a real kubelet, Quark is with fake kubelet. Or something like that. So, but this we'll mention later as well. There's some details. And also, for large cluster, you may have a local registry like Harbor or some CR proxy. There's many choices here. I mentioned several solutions, but this is not all of them. As you can find more in the CNCF landscape. And here's some Kubernetes community updates. I just I talked with Virtech. He has a keynote, which is a virtual keynote. So I think many people may miss it. So I give the keynote link here. He talks about the 15,000 nodes cluster feature of Kubernetes. 2021 or 2022. And here's a list of caps which is related to the large cluster, especially the etcd service overrides for sharding. This really helps. And I talked with etcd maintainer. He mentioned that if you use this with the node list, the list is for separated etcd cluster, then the cluster can be around 30K nodes. And before in 2019 we have the node heartbeats, and also later the watch bookmark, and the endpoint slice is also a very earlier change. And you can see the list. There's many changes in recent years, 2023 and 2024, and also in recent in the latest release. The current release cycle is 1.33. There are many changes which is related to caching or streaming or something like that. There's many updates recently. So if you want to build a large cluster, maybe you can try to test on the recent versions. And also, the proxy NF tables will be GA in this release. This is about etcd. etcd, for the native etcd, there's some improvements, especially in the 3.5. Wilson and Justin has a video about this for the performance change of etcd this version, and you should take care that there's a minimum of recommended etcd version for 3.5. You should use the patch after 6 because there are some critical issues. And recently, the Google replaced with Spanner. They can have more nodes. Before we talk about replacement solutions, we can check how can we reduce the pressure on etcd. First is about the API server. Use the limiter ranger and use the resource quota, and also some read cache. You can see the architecture. Those things can help you to reduce the pressure. For example, if you have a daemon set which connects to API server with a lot of API calls, the API call is expensive sometimes for the daemon set, so we should avoid using it. And also, there are some validation policies, and like OPA, kernel, and validation or something like that to reduce the etcd pressure. And just mentioned, etcd overrides the servers. This is generally used for events. And now we can see the list is one of the pinpoint. So sometimes we use it for lists. And in some cases, if your operator or you have the custom API, you may use it for your custom API group. This also helps. And sometimes the pods is one of the largest object. It can also, you can use more than 2 etcd clusters. Then about Kubernetes, this is not quite related to, because Kubernetes will connect API server, so the Intl and the QPS API burst, you may need to tuning them, and also the node update frequency. This is for the node list. And for etcd, there's a tuning page in the official website. You may have the better disk, and also the network, also the heartbeat intervals. And for the replacement, Kubebrain is an open source project for ByteDance. They use it with 20K nodes. And they will have a talk in KubeCon NA24 China in Hong Kong this June. And but there's some the project has some limitation because some API related I forgot the details. It is only support Kubernetes 1.25, and also there. If you want a better performance with their solution, you need a special patch, which is not open source yet, but they plan to open source it later. And I hope and look forward to their update. So we may wait for their updates later. And for other solutions like kine, in last KubeCon North America, there's a topic with kine, and this is an interesting topic you can check. But kine is always used in some edge scenario. So for the large cluster, we need some test. And also, you should before everything, you should test your cluster with huge clusters. But it needs so many resources. So Quark is a good choice to fix quite a lot of nodes. This is used quite in many scenarios. At first, Quark is used in the scheduling performance test. Yesterday, there's a talk about this. So you can check if your scheduler works well on the large cluster. And also, Quark is used in some UI-related project like the headlamp. Also, you use the Quark to mock some nodes and some status. And also, you can test your control plane. So the key takeaway here is the key takeaway here is the replacement solutions and the community updates, and also you need to do the performance test before. And what's more, multi-tenancy and multi-cluster is the popular questions. And why not multi small cluster? This may be mentioned by my co-speaker. So I think this is similar to the question why we use a light cluster. It's just vice versa. And also, last year there's a multi-cluster application management radar. This mentioned the projects related to multi-cluster. So you can check those projects for your solution.
Awesome. So I hope you remember this particular slide, like the poor tenant isolation, large blast radius, reduced end-user flexibility, and the version selection stuff. So let's try to see if we can simplify that or if we can solve these challenges so that with the points specified for the huge cluster, this can also work, like we can find some solution for the cons which are there. So what we are doing right now is if we have three different teams who want to apply or deploy their applications. Everybody does, kubectl apply -f their deployment.yaml file. It talks to the API server of the Kubernetes, and then it creates the replica set, and the deployments for each team. The problem here is sharing. Yes, we are sharing, which is good. We are trying to share the same host cluster, but the problem here is it's the same API server that is getting hit, and what do? So we create something native, which is called Kubernetes namespaces. So in Kubernetes, there's a concept of Kubernetes namespaces. And in Kubernetes namespaces, there are a lot of things that you can do. Like there are a lot of resources which are namespace scoped. For example, if you can see, there is pod security, policies which are pod security admissions enforce, restricted that you can do. There is network policy that you can do to restrict the traffic from one namespace to another namespace, and you can curate it in a way that a tenant in a namespace A and a tenant in a namespace B do not talk to each other at all, but they're able to talk to the API server. So this is something it looks like. And then there is other like resource quota, limit ranges, all that stuff is namespace scoped. So where we are now, what we are doing and what people are doing and what you have specified in the survey as well, there are many clusters. There are big clusters, and then there are many clusters for different teams. There's cluster per team, there's cluster per environment, and then for each Kubernetes clusters that is created, if you want certificates, if you want all that things, so you will be installing cert manager, you will be installing ingress controller all over through all the clusters, because there's no other way. Key issues with the namespace-based approach is it becomes very difficult when it comes to different or multiple tenants. Let's say team A wants 3 namespaces, team B wants 2 namespaces. How do you distribute the kubeconfig files? How do you do the cluster level resources? CRDs is a big pain. And how do you test different versions of CRD? Let's say you want to test out CRD of different versions for your operators. You want CI testing on different versions of Kubernetes clusters. That is another issue which is there. So different version of your applications or different versions of Kubernetes clusters is also a pain which is difficult to manage with namespaces. So this is a very interesting spectrum that I would like to cover, which is that this was image was created by LearnK8, so credits goes to them. So if you see, we have on the left-hand side, we have namespaces that we already discussed. On the right-hand side, and on the next, as we move on, so the next part is namespace as a service, where what it means is all the constructs of the namespaces, like the resource quota, limit ranges, network policies, are grouped, and then they are intelligently provisioned. For example, you have the projects like Capsule that can do that, hierarchical namespaces. Yeah, they're able to do that, but it's not that much maintained. And then you have the Kubernetes API as a service, where you have a certain type of proxy in front of the API server that does the filtering of what user is allowed to see and what is not allowed to see. For example, for the previous model that I mentioned, namespace as a service, it's difficult still for the CRDs because you can only limit by the namespace scoped resources. And when I'm talking about the Kubernetes API as a service kind of scenario, which falls for the third layer. So you have the capsule proxy over here. KCP does some sort of this as well, falls into this particular category. This helps you in having those CRDs as well limited to the view of particular team. Let's say team A only needs to see certain custom resources, team B only needs to see certain persistent volumes, so they will be able to do that. It's a bit hacky, but yeah, it works. And then you have, let's talk about the dedicated clusters first. So there is a thing, what you can do is, here dedicated cluster means still each user gets their own cluster, but it's still expensive, and but it's more of the like strongest isolation that you need. So if you need hyper strong isolations, you need to go for the kind of separate Kubernetes clusters. So here there are some projects that helps you do that, but here you have to have those control. For example, you have Karmada over there, you have kubeslice. So what happens is, if you have Karmada as a cluster, so you will be having a Karmada control plane as one cluster, and then you will be having multiple teams. Multiple teams will be having multiple Kubernetes clusters. Each cluster will be having an agent that connects back to the Karmada, and then the deployments happen in that particular flow. So that is one way, and there are multiple tools in this this space as well on the right hand side. Now, two interesting pieces, which is very interesting for the Kubernetes multi-tenancy. One is control plane as a service internal, one is external. Here what we are trying to say is running control plane as a pod. So we are running control plane as a pod. Coming to the external one, where you see more of the Karmada or the vCluster Pro or K0s Moton or the Hypershift. You will be having a management control plane. In the management control plane, you will be creating the control plane pod. Then you will be having the worker nodes that you set up. For each of the worker nodes, you will connect those kubelet, you'll have the kubelet and stuff, and then you'll connect back to the control plane pod in the management cluster. Now this becomes one cluster. If you want another cluster for team B, what you do is you spin up another virtual machine, install kubelet over there, connect to the control plane. You create another control plane pod for team B on the control plane cluster, and then you are able to connect. Now this sort of scenario is useful when you're talking about, like it's mentioned, external. When you are providing kind of Kubernetes as a service, when you want to provide that as a service, this model kind of works well. And the last one is where you don't want another Kubernetes cluster. You have existing Kubernetes cluster, and you just want to reuse that. So you have the control plane pods running on the clusters for different teams, and they will sync the resources in the host cluster. So that's how it is. That's the complete spectrum. So these three things we need in multi-tenancy with the complete spectrum. Another problems is the resource sharing. So even if you have all the stuff that I mentioned previously, all the teams, we do not want them to have separate ingress controller, cert manager, and all those components. At least there are certain set of components which should be shared across, certain policies, Falco, Kyverno, Nginx, controller, cert manager, which is there on the host cluster, and I do not provision them again. That was one of the pain points of the huge cluster. This is where I would like to introduce one project, and obviously we cannot discuss all from the spectrum. So one is vCluster. What vCluster helps you do is, vCluster is an open source project that helps you create virtual Kubernetes clusters on top of the host Kubernetes cluster. And it's the cluster that you get. It's a kubeconfig file that you are getting, and the model is same. It runs a control plane pod, which is running as a stateful set on the host cluster. And then when the team gets it, let's say this is team A, team B. So team A will be only able to deploy workloads to team A's cluster and not able to see team B. And they get a CNCF certified distributed Kubernetes cluster. Team B will be able to deploy anything. Team A can have Argo CD version v1, Team B can Argo CD version v1.2. Team A can have a Kubernetes cluster with version 1.31, Team B can have a cluster with Kubernetes version 1.32. Team B can decide to upgrade their Kubernetes version to 1.33. Team A can say, I do not want to upgrade it to 1.32 or 3.3. So CRD testing, you can have your different versions of operators that you can install on different virtual clusters. And remember, this is the same big cluster that we are talking about. but we are having multiple clusters. So it solves many of the challenges that we discussed if we have the bigger Kubernetes clusters. So that's how it works. I talked about the syncer when I was explaining that, so that there is a syncer component, and most of the tooling in that area like K3K, vCluster, they will be having this syncer component. So, or a way to sync the resources. So in vCluster, what happens is, like you said, when the user runs the command, it goes to the control plane of the virtual cluster, so there's no performance overhead. And as soon as you create everything, there's a syncer pod that copies it on the host cluster, and then the regular scheduling takes place on the host cluster, which is there. So I have a quick demo. It'll take just 1 minute. You can try the demo out on your own as well. Let me just show that. Okay, I need to close this. Yeah. So kubectl get nodes. So I already have a 3-node Kubernetes cluster which is running. What I do is I'll just create vCluster create demo cert and just pass a vCluster YAML file. What I want to show here is how the vCluster is created and how the behavior looks like. Right now it has started to create, and if we see here, and kubectl get pods -a. So we have all the pods which are running. This is the host cluster. So as an admin of the host cluster, obviously you see all the pods which are running. But what is happening is you can see there is a stateful set. So this is the control plane pod that is coming up on the host cluster for the virtual cluster that is being created. So vCluster is being ready. The pod is in the status. So it is, hoping to run. Yeah, it's in the container creating state, and soon what will happen is suddenly I do kubectl get pods -a and I don't see any other pod. I only see one pod, which is the networking pod. Why is that happened? That happened because the cluster created a new context, and it automatically switched to the new context. So that's the kubeconfig file that you can hand over to the team. So you can apply the applications. You can apply issuer, and you can create. And you see on this cluster, I haven't installed ingress controller, I haven't installed cert manager because I have synced those in the vcluster.yaml file. Apply -f certificate and kubectl apply -f ingress. So yeah, I hope I have deployed the issuer, certificate, ingress, and the application. Yeah, all these components are created. So if we do kubectl get ing, it might take some time for the certificate to propagate, but at least the link should work. Let me see if I can scroll back into the screen. Okay, it has come. And if I paste, well, welcome to KubeCon EU 2025. Thank you. And so in the end, we just want to say that there are huge clusters benefit for that. There are small clusters benefit for that. As Paco mentioned, there is fine tuning that can be done for the huge clusters with different set of components. There is multi-tenancy with the complete spectrum, which has different tools and cater to different use cases. So based on what is your requirement, what do you want to use, you will be using from that particular spectrum. One of the tools I showed, vCluster. vCluster, we have a booth of vCluster. If anybody wants to talk more, you can find me in my fancy jacket. And at the vCluster booth, I'll be happy to answer any questions. I hope they don't kick us out because we are already 4 minutes over. We'll be around for the questions until the next speaker comes in. And thank you so much. Thank you for coming.